All right, welcome back, AP Calculus. This is our next section, 2.5. We're looking at one-sided limits. And in this lesson, we're going to approach the roller coaster or the graph from one particular side. So let's look at our first example. Let me move this up to the top. All right, so here's our graph, and here are some limit questions. And so for the first example, we're asking the limit of f of x. So maybe I'll just check it off so you can see like where am I? So right now we're gonna do this letter A, this example. Actually, let's just label these so you know which examples we're referring to. And I'm gonna label it going down. So this will be B and C, D, E, F, G, H, I. All right, so for example A, we're asking what's the limit of f of x as x approaches -4 from the right side. So the right side of this roller coaster, and let me get my pointer. All right. So as we approach -4 from the right, we're on this roller coaster ride. We're on the roller coaster ride. We're going towards -4. -4 is over here somewhere, right there. X is -4. From the right side of the graph, we get to this y value. And that y value is 3. So that's your answer for letter A. What just happened there? Let me move this to the side. Okay. So sorry about that. I think I clicked zoom and it was like some different video. All right, so we said the y value was negative. The y value was 3. All right, so for letter B, back to pointer. As x approaches -4 from the left side, so here's -4, and we're approaching this value from the left side. So as we get closer and closer and closer to -4, we get to that y value. That's -4, and we approached it from the left side. So the y value there is 1. So that's our answer, 1. For letter C, as the limit of f of x, so our function is that graph, right? That graph is our function. I know there's holes, there's these breaks in the graph. And so for letter C, what's the limit as we approach -4 from both sides? I want you to notice that from the left side of the graph, and I'm going to highlight this in yellow, from the left side of the graph, we are going to -4 and we approach this value, open circle. From the right side of the graph, as you get closer to -4, that's supposed to be an arrow, you get to this dot. But you're going to two different y values. At one point, from the right side of 4, you go to 3. From the left side of 4, as you approach 4, as x approaches -4 to be exact, we get the y value of 1. Because those are different y values and the lines don't meet, we're going to say that the limit does not exist because those y values are different. So the answer for letter C is does not exist. Back to the marker. All right, here we go. D and E does not exist because again, the lines in the graph don't meet at the same place. For letter D, the limit of f of x as x approaches 2 from the right side. So this time we're going to 2 from the right side. So here's the right side of the graph. Let's go to 2, follow the roller coaster, and there's 2. The y value is 3. How about we approach 2 from the left side? So here's a roller coaster. That's to the left of 2, going towards 2, and the y value is still 3. So from the right side of 2, we approach 3. From the left side of 2, we approach 3. And since x approaches 2, from the left side is the same value as we're approaching from the right side, right? We're going to that 3, the y value of 3, then the limit does exist, and this is 3. So that's limits problem as you approach from the right side, and that's what the little plus means. This little plus right there means approaching from the right side. And that little negative means you're approaching 2 from the left side. Approach from the left side. Left side. So let's look at letter I before we get to those infinity ones. In letter I, the limit of f of x, so the limit of this function of the graph, as x approaches 5. We're approaching 5, but from which side? From the left, right? There's a little minus sign above, next to the 5, above on top of the 5. So we're approaching 5 from the left side. So to the left of 5, let's get to 5, let's get to 5, let's get to 5, and the y value is here. The y value is 0. So that's the answer for that problem. Now we get to these infinity ones. So the limit of the function as x approaches negative infinity. What that means is you got to look at your graph, just follow the graph, make x go all the way to the negative value as possible. So here, where the pointer is, we're at 7. Just follow the graph, make x. I know there's a break in the graph. This is called the jump discontinuity. We'll talk about that in the next lessons. So there's a break in the graph. This is a jump discontinuity. So then you keep following the graph as x gets more negative, more negative, more negative. Keep going. Notice this graph is going up, 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 up to what value? The y value. The y value goes up to positive infinity. So as x becomes more negative, the graph is going up and is becoming more positive. The y value is becoming more positive. So this particular answer is infinity, positive. Take a moment to think about that. Think about why. Try to make sense of that in your own way. Feel free to pause the video. All right, for letter H, as x approaches infinity. So as x gets bigger and bigger and bigger. So here, just follow the graph. We're gonna make x bigger and bigger and bigger. X is 1, x is 2 here, x is 3, x is 4. The x values are getting bigger and bigger as you're following the graph. At this point, there's this constant line, meaning the line's not increasing or decreasing. The line is just constant. It's a straight line as x gets bigger and bigger and bigger. And so this value looks like it's 5. Would you say it's 5? And so that would be the answer for that problem. As x approaches infinity, the y value is constant and it's 5. All right, let's continue. So now we're going to look at one-sided limits using a table. So we're going to look at these limits numerically. Evaluate. Move this up a little bit. Evaluate. The following one-sided limits. If it exists. So the problem is the limit as the limit of radical x plus 3. And I want to say we're going to look at, let's change up the problem. Let's do something else. As I'm writing this, I'm thinking of a different problem. So let's do this. 1 over x minus 3 as x approaches 3 from the left. So that's our limit problem. Evaluate the following one-sided limit if it exists. That's our example. So in this limit problem, we are approaching 3 from the left. So if we do a number line, not a number line, a little grid, sorry. If we do a little grid and we're getting close to 3, so let's put 3 just here. Just put 3 right there. And that's the x values. And we're trying to figure out what are the y values. So what's f of x? What are the y values? So we're approaching 3 from the left side. So as you approach 3 from the left side, you want to think what number is next to 3, immediately next to 3. Now, again, you might say 2.5, but I bet you there's a closer number next to 3, and that's 2.9. And I bet you there's another number closer to 3, and that's 2.99. So you want to just get as close to 3 as possible, in this case from the left side, right? There's that minus symbol, and that minus symbol next to the 3 above the 3 approaches 3 from the left. All right, so what we're saying, if we were to just write some of these out, we're saying, well, find the limit of 1 over 2.99 minus 3. Well, actually, let me erase this part because we're evaluating. Let me get my eraser. We're evaluating, so it's already, you don't need the limit there. All right, so we want to figure out what that is. What is 1 divided by 2.99 minus 3? I have my calculator on a different computer, so feel free to calculate that on your calculator as I do on mine. So we have 1 divided by parentheses 2.99 minus 3. Actually, and I'm going to show you some of the steps. I'm just gonna do the denominator, 2.99 minus 3. I want you to see what happens. So here, if you evaluate this, right, and we're doing this guy right here. We're plugging in. Let me get back my pen. Where x is 2.99 minus 3. 2.99. X is 2.99. So that's the problem we're doing. We are evaluating that into the problem 1 over x minus 3. So 1 over 2.99 minus 3. The 2.99 minus 3 part gives you negative 0.01. Next, the 0.01 is the same thing as saying negative 100. Let me just double check my math here. 1 divided by 100. Yep, that's 0.01. Okay. And if you take the number 1 and you divide by 100, negative 100, okay, there's a little mistake. Let me fix this. This part right here. The 0.01 is this guy right here is 1 divided by 100. That's what that is. So 0.01 is the same as 1 divided by 100. Now, to get rid of that fraction, I'm going to multiply by the reciprocal on the top and on the bottom. That 100 eliminates, and you get 100. So this, and that was a negative 0.01. So this should have been a negative 1 over 100. These hundreds cancel. So you have 100 over a negative 1, which is negative 100. So this is negative 100. We'll do it again with a 2.9 so you can see what happens. So you have 1 over 2.9 minus 3. We're plugging these numbers in. Let me get a yellow marker into this function right here in yellow. We're plugging that into this yellow function right there. So x is 2.9. So instead of x, we plug in 2.9. So now 2.9 minus 3. That's what we're going to type into our calculator. And you get negative 0.1. So you have 1 over negative 0.1. But negative 0.1, you could rewrite that as 1 over 10. So 1 over 10. Next, we got to eliminate that fraction. Hold on, let me charge my Surface Pro before this thing logs off and gotta redo this whole video. All right, so we gotta get rid of that fraction. So we're gonna multiply by 10 on the top and on the bottom. These 10s cancel. See what I'm missing again? Did you catch that? That little negative sign, I forgot, but I remembered. So there should be a negative right here because of that negative right there. So we end up having a 10, a negative 10 as our answer. So that's this guy right here, negative 10. Now I want to get as close to 3 as possible. So I'm going to do one more example. Let me erase this 3. Can I erase? Not letting me erase. There you go. I want to write that 3 a little bit. I want to write that 3 right here. Just because I want to try one more example for you guys. 2.99. I'm up 99. So there's 3 9s. I'm approaching 3 from the left side. So 2.999 is much closer to 3 than 2.99. So one last example. So if we have the original function 1 over x minus 3, but instead of x, it's 2.999 minus 3. Type that into your calculator, and all I'm typing in is 2.999 999 minus 3. 2.999 minus 3. That's going to give me negative 0.001. So what I want you to understand at this point, if I don't know if you're seeing the pattern, I'm going to write this in red. As the denominator gets smaller, as denom gets smaller, let me move this up a little bit. As our denominator gets smaller, our answer gets bigger. So what do I mean by that? Well, you have 1 divided by a negative number. That negative 0.001 is the same thing as saying negative 1 over 1,000. So that decimal is getting, on the denominator, this decimal is getting smaller and smaller and smaller. But if you do the math operation to get rid of that denominator, the 1,000s cancel, and your answer gets bigger, negatively big. So our answer is negative 1,000. Let me move this back down so we go back to our table. So this is negative 1,000. So as x approaches 3, okay, let me get that pointer. As x gets closer and closer and closer to 3 from the left side, because that's all I care about, the y values are approaching a certain number, negative 10, negative 100, negative 1,000. Take a guess. What do you think we're approaching? Negative a big number. And so we're approaching negative infinity. So here I'm going to say the question mark, what are we approaching? And we're going to take a guess. We're going to say our guess is negative infinity from the left side. Okay, so our answer, I know it's a little bit messy, but math is messy at times. So we're going to say, to summarize what we just did here, you had a limit problem, limit of 1 over x minus 3 as x approaches 3 from the left equals negative infinity. All right, I'm going to share my screen so you can see this graphically. Share screen. Here's my TI-84. As you can see, I was doing the calculation on the TI-84 right there. I'm going to go to y equals. We were graphing the fraction 1 over x minus 3. And the graph looks like that. Another type of zoom function that we could do is you could do zoom box, Z box, number 1. If you press enter, you have a little cursor. So what you're going to do with the arrows is you can create a box of where you want to zoom in. See the little cursors moving around? The moment I press enter, so the limit is as x approaches 3 from the left. So let's just do something like this. Enter. So I'm gonna draw a box. I'm just using the arrows to draw this box. Then when I press enter, it just focuses the zoom window in that region. All right, so trace. So this time the trace wasn't at the origin, but that's okay. You know, we got our blinking star. The question is, what happens when you get close to 3? So this value right here is 1. The x is 1, x is 2, x is 3. So as the cursor gets closer and closer to the little blinking star, gets closer to 3, look at the y values. Negative 4, negative 6, negative 14, the y values. Oh, the y value jumped over to the other side of the graph. But if you were to look at the y values, we're going down. We're going down, we're going down, we're going down to negative 14 right now, and it's going to keep going down to negative infinity. So that's how that looks like. Now, you're seeing a window, you're just seeing a portion of the graph. I think what we'll do justice is if I share another screen and I show you a different way. So let me share some other screen. Share Desmos. I think that might be better for you. All right, so 1 divided by x minus 3. Same graph. Now I'm gonna do is zoom out. Do you see how the graph, oh, I can't move. Oh, but I can do this. Okay, so as I get closer to 3, as x gets closer to 3, 2.6, look at the y values. Negative 6, negative 7, the y values are getting negative big. And I can keep zooming out. And do you see how the red line keeps going down, 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 very much down to negative infinity? And if you keep zooming out, you're at negative 400. So that's how that graph looks like, and sometimes the TI-84 doesn't do justice as Desmos does, but at least you can see as you're going to 3 from the left, you're approaching a negative big number. All right, that was that. Going back to our whiteboard this time. That was that lesson. We just got 2 more examples and we're done. Thank you for still being with us. Let's continue. All right, here's your next example. The limit of tangent x as x approaches pi over 2 from the right side. Plus sign means right side. So I'm going to draw the graph for you. Actually, yeah, just have it in your notes. So the tangent graph has these asymptotes at pi over 2. And there's another asymptote at 3 pi over 2. And on the opposite side of the positive x-axis, negative pi over 2. Now let's draw the tangent graph. Well, let's draw these asymptotes too, so you know that you're not going to touch those values. These are the asymptotes. So our graph goes through the origin. The graph increases, goes through the origin, keeps increasing, but does never hit pi over 2. And then at the bottom, underneath the x-axis at pi over 2, the graph does the same thing, comes up, comes up, comes up. There's a point where it crosses the x-axis, and the graph comes up, but never touches 3 pi over 2. And it's a repetition. So that's the graph. The question is, what happens as x approaches pi over 2 from the right side? So we're getting closer and closer to pi over 2. What's the y value? The y value is somewhere up here, and that's positive infinity. The graph goes up, 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 up. As x gets closer and closer to pi over 2, you'll never reach pi over 2 because that's an asymptote, but you're going to keep getting closer to it. And as the graph gets closer and closer to pi over 2, you're approaching a y value that's super big, and we call that infinity. So the limit equals positive infinity. You don't have to write the positive symbol because we know if you don't put it, we know that it's positive, but that is the answer. All right. Just looking at my notes here, I have just a couple more examples. I think I have just trying to see, okay, well, look at this example. This will be our last example. You're like, but he said that last time. I say a lot of things. Here you go. Example. But I think this was because I said we had 2 more examples, so I think this was the last example. X minus 2 over x squared minus 4. But this example, like, I mean, I know I wrote example there. In order to do this example, let's take away this minus sign. Can I get rid of this guy? Okay. So in order to do this example, let's say this was our limit problem, just like that. So x approaches negative 2. Question for you guys is, what would you do? What do you do first? Remember like our steps that we talked about previously in our previous lesson? Plug and chug. So that's what you would do first. So I want you to try to plug in -2 mentally into the problem and see what you get. You plug in -2 in the numerator, you get -2 minus 2, which is -4. Okay, so you get a number. And if you plug in -2 in the denom, you get -2 squared, which is 4, and 4 minus 4 is 0. The denominator becomes 0. And that's a problem. That's undefined. So by you plugging in -2, you get an undefined answer. And so maybe we have to figure out, well, what are we approaching from the left, from the right? Like, what are we getting towards? We know the answer is undefined, but the question is, can we figure out? That's what calculus is about. Can we figure out what are we approaching if we're not at -2, but if we're at a number close to -2? That's the big idea. So let's get close to -2. We're gonna do this like this. The limit as x approaches -2 from the left side, and you have x minus 2 over x squared minus 4. X squared minus 4, that's a difference of squares. So I'm going to factor that as x minus 2, x plus 2. I could cancel out the x minus 2's, and I have a 1 on the numerator. And I have x plus 2 on the denominator. Now I could try doing plug and chug again. -2, plug in -2 into the problem. But by plugging -2 into the problem, I still get a 0 on the denominator. But at least it's not that complicated anymore. At least the problem is not that complicated. I can approach -2 from the left side. So in a way, I'm kind of like plugging and chugging, but I'm plug and chugging a number that's to the left of -2. So think of a number line. Here's -2. Here's -3. To the left of -2 is somewhere there. -2.0001. -2. Because we're approaching -2 from the left. Remember that. Let me put that in red. We're approaching -2 from the left side. That's why I drew the arrow like that. And that's -2.001 perhaps. And we're going to add 2, which means you have 1 over those 2's canceled, the -2 and the +2, and you end up with 0.001. 0.0001. 1 divided by a small number equals a big number. In other words, infinity. As x approaches -2. Let me share my screen and let me just double check our work here. Continue. I'm going to share my screen. 1 over x plus 2. Let's see if this is correct. 1 over x plus 2. As x approaches -2, so here's -1, and here's -2. If you see the cursor, I think you see the little arrow. We're getting close to -2 from we said from the left side. So as you get close to -2 from the left side, here's -2, then we should be approaching -infinity. So let's go back to our whiteboard. There's something that's not quite right. As you're approaching -2 from the left side, we should be approaching -infinity. Oh, okay, I see. So when you subtract -2 with a little piece more, this little piece more, then you still have that negative there, right? You have -2 and a little bit more, plus 2. So you still have a negative. So 1 divided by a negative number, positive divided by negative is negative infinity. This should have been negative infinity. So that's the answer for that part. What about as you approach -2 from the right? So we're going to look at the right side now. You saw that graphically. You might remember the answer, -2 from the right side. X minus 2, x squared minus 4. That's the original problem. But now we're approaching -2 from the right. The limit as x approaches -2 from the right side, x minus 2. You factor the denominator, x minus 2, x plus 2. The x minus 2's cancel, just like before. Now we're going to do plug and chug. But when you do plug and chug, -2 into the original problem, that's a problem, right? You can't have -2 plus 2. That's 0 on the denominator. Can't have 0 on the denominator. So I'm just going to write limit as x approaches -2 from the right side, 1 over x plus 2. Then instead of plugging and chugging -2, let's try another number that's closer to -2. So using our number line, we're approaching -2 from the right side. So what number is right there? I'll do that in red. What number is right here? On the right side of -2. Here is -1. On a number line, this is 0. Think about what's on the right side of -2. And that number should be -1.9. So right there, -1.999, that's closer to -2. So going back to our problem, if you substitute -1.999 plus 2, do you have more negatives or do you have more positives? In this case, you have more positives. 2 is way bigger than 1.999. So your answer is 1 over 0.0001. Is that what it is? 0.0001. Let's double check. Just going to type that in. You have -1. I'm just using my calculator. -1.999 plus 2 and 0.001. So just 2 zeros. So let's erase one of those zeros. There you go. And 1 divided by a small number is a big number, and this number is positive infinity. That is the answer when you approach -2 from the right side. So I'm going to share my screen again. So in case you forgot how the graph looks like, this is the graph. -2 is right here where the cursor is. Do you see how from the right side, when you approach -2, you're going up to positive infinity? You're going up, up, up. And -2, when you're approaching this -2 value from the left side, you're going down, down, down. Because the graph does not meet at the same place, from the right side, you're going up. From the left side, you're going down. The limit does not exist. That's our answer. Since the limit as x approaches -2 from the left side of x minus 2 over x squared minus 4 is not the same as the limit as x approaches -2 from the right side of x minus 2 x squared minus 4, right? Because this guy right here was negative infinity, and that's not the same as this answer, which was positive infinity. Thus, limit as x approaches -2 of x minus 2 x squared minus 4. And that's the original problem that we started with. The original example, you could kind of see it. Right. Oh, sorry. You could kind of see it right here. That we were approaching -2. We didn't say left or right. We just said approach -2. But because from the left side and the right side, we're going to different values, then the limit doesn't exist. Because the y value could be -infinity or +infinity. Therefore, the limit of that problem does not exist. That's the answer. Thank you guys for checking in. We'll talk more about limits in class. Take care. Good night, good morning, whenever you're watching this video. Bye.